Hello guys, this is my second video of in the playlist of the 500 projects. So I will be doing a project on quality of wine. We will be predicting the quality of wine from some training data set. It is actually a Kaggle problem. If I try to Kaggle, Kaggle, I'm showing you the problem. Quality of wine, quality of wine, prediction of quality of wine. Because I've already downloaded the dataset, and if I can show you, yes, this is a caution, like a problem statement. The two terms are related to red and white. You can read it by yourself. I will I will drop the link in description of my video, and you can download the CSV file from here. And I think I should start the project. I will be also showing you how to make environment using Anaconda prompt, and that's how we are going to make. First, we need to specify the path where we will where will we having our data set. So I'm just copying this path, and we need to type cd. This is a basic command of cmd. Now we have entered in the data science project number 2, quality of wine, and now I just need to create the environment. Conda create my environment name. Actually, my name, my I will be giving this as ds2, because this is a data science project number 2. So I'm entering it. This is our name of environment, and now we will wait. It is collecting packaged metadata. Now we just need to activate our it is asking why to proceed or not. I'm putting why and proceed. Now we need to activate ds2. Now it is activated, and now I can just write Jupyter notebook to open the Jupyter notebook itself. And also we need to open another command prompt, Anaconda command prompt, and it will be helpful to install our new packages when I am uh, which I will be going to use in my project. So the Jupyter notebook has getting been started. You don't need to actually open the Anaconda. I've just opened it by mistake. This is our Jupyter notebook shell, and I just need to click on new and Python 3. Actually, this I've mistakenly opened this Anaconda launcher. Uh, I instead wanted to open the Anaconda command PowerShell prompt. I need to go again. I don't want Anaconda Navigator. I just want to quit it. CD, and I will be getting into this again. Activate ds2 is. Now we will be starting our project from here, and let me change the name ds2 rename. Now the first step we need to start our project is by actually importing the main libraries. First we need to import our data file, CSV file. So for that we need to import pandas as pd. And now I want to import the data. Then simple command is like pd dot read underscore csv. We need to specify the path here, like what name our csv file has: wine quality slash red, and csv wine quality slash red dot csv. Am I right? Let me check it again. Red wine quality so minus red. See, successfully imported our data file. I just want to read it. Then we need to just put the. I want to show the head of our data set, and this is our command. And now you can see this. This is actually our data set, where we have features like fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, and all of these. Now we just want to know about the some basic info about this data frame. So there is a simple command like wine.info, and we just need to press shift and enter. Then it will be showing like there are 159 null. So I think all of we can also check the length of the data frame by length wine, and it's actually 1599. So there is no null values in any of the columns, so we are fine with it. These are the actually columns: fixed, acidity, volatile. These are actually the columns. Mainly the features are the columns, and these are the rows. Like these are the rows that index number, like this is the row. And we just need to move it forward. Like we have now we have seen that there is no null value. So now we need to do some exploratory data analysis. Okay, let me mark it here. EDA. Okay guys, now we for that we need to import like matplotlib and seaborn. It will be helping us to visualize our data easily. Matplot, pyplot, splt, and I will also be import seaborn as sns. Now I'm going to press shift and enter. Matplot, actually it's matplotlib. Now it's running, and we will be going forward with this. Just wait, it is running. Actually it is taking some time. After that we need to make some visualizations among like we need to know about the quality. So there is our quality feature at the end, and this is basically like I can if I can show you. Wait, df dot quality. Actually quality is in small letters, all small. So let me copy paste quality dot unique. df is not okay. I have put a wine for the data frame. Now you can see that there are actually there are only 1 2 3 4 5 6 unique. There are only 6 unique variables in that features like equality. And we want to if we want to calculate the quality by with the help of these with these other columns. These are actually the features which will be going to help in finding the quality of the wine. And we are going to use all these features in making our model. Now as we have started the ADA, now we want to some like plot a graphs, basically like between quality and a fixed acidity, if we want to like check how the relationship is going between them. So for that, figure size, figure is equal to plt dot figure, and fixed size fixed size is going to be like 10 comma 6. Now need to go in SNS dot bar plot. We are actually plotting a bar plot between quality and fixed acidity. So for that, x coordinate will be going to be our quality, and y I will be taking as a fixed acidity. Fixed. If there is any space, or there is space, so x acidity I have right. And now we need to mention about the data. So data is equal to our wine data set, and there is no double equal to it. It will work without even that. Now it has printed our bar plot between fixed acidity and quality. We having the quality as in our x-axis, and fixed acidity is we will be having in our y-axis. And now you can see that quality was ranging between 3, 4, 5, 6, and 7 and 8. As we you can see that 3, 4, 5, 6, 7, 8. Okay, now you can see the quality of 8, the quality of 3, the wine which is having the quality number like 3 is having fixed acidity around 8 plus, and as follows. Now we can actually plot that graph between some other features, like like forward we have volatile acidity. I can copy it. We just need to copy and paste it over here, like replacing the fixed acidity with volatile acidity, and it is showing me error. Is this or something? Okay, now it will be showing us the plot graph, and now you can see the same type of like graph we have plotted, bar plot, and it is actually showing that the quality of wine, the number 3 quality of wine is having like 0.9 0.8.3 something like volatile acidity. And we just for we just don't want to read about the volatile acidity as a being a fresher, because there are so many different projects, and all of them having different features. If we are going to concentrate on reading all of these things as a beginner, then it will be going to difficult for us. But as a trained person, as we have successfully took 2 or 3 years in data science, then you should be doing a research before starting a project. You should know about how is fixed acidity is valuable for predicting the quality of a wine, of a red wine. So I know if you are getting, if you are getting me. Same thing we will be doing with that with other features like next thing we will be having like citric acid. We will be doing this thing with the citric acid as well. Just copy paste and see if it can give you a meaningful data. Like now you can see having a quality the quality 8 of number wine is having the highest amount of citric acid. It means like uh, the higher the citric acid in a red wine, the more the good quality of wine it will be there. So, uh, and the opposite is in here. If the volatile acidity is higher in red wine, then the quality of wine will be less. So let's move forward. Next is our residual sugar. Now I need to copy it, just paste it over here. It's about residual sugar, and just need to copy paste it. Like now you can see that residual sugar is not that important in such a case. Residual sugar is like a variable type of thing. It is actually somewhere it is like high, somewhere it is around low. It is actually not a part of not a part where we need to use it as a in predicting the quality of wine. So now I think we should move it forward with we have now chlorides. Now we can use it as chlorides in here. Chlorides. Yes, now you can see this chloride is important for predicting the quality of wine. As you can see, the number three, the quality of three of red wine is having the highest chlorides level. So let's move forward with the next. We have free sulfur dioxide, like free sulfur dioxide. You just need to copy paste. Oh, now you can see like if the amount of free sulfur dioxide is a little higher in the wine, then its quality is getting decreased. But as a particular amount like around 13 or 12.5 amount of free sulfur dioxide is making some really good type of red wine. So now you can also see if the amount is less, then it is also going to be bad, and if the amount is going to be more high, then it is going to be a bad quality of wine. So minimal amount, like um, average amount of free sulfur dioxide is going to give you a good quality of wine. So our next step is total sulfur dioxide. So just need to copy it, paste it total sulfur dioxide instead of residual sugar. Now we can see same thing is going over here too, like I've explained in free sulfur dioxide. Now move it into the next density. we are actually basically doing ED over here, and this is not something like difficult part, but you need to like makes a search, make some like good meaningful visualizations from your data set. See, density is not density is always same, so the quality is it means quality will be going to be remain same, because if we have three number of four, five, six number of quality, then also they all are having the same amount of density. So density is also not necessary over here. And then we need to do a pH value as well. pH value pH value pH please no, let's just keep it up. pH value is also not giving us some variable type of graph, like it's not fluctuating. Now we need to like do with it with sulfates and our sulfates and with alcohol. So let me just show you sulfates, and same thing we are going to do with alcohol. alco- Alcohol. alcohol. So now you can see these both graphs are showing that higher the amount of sulfates, higher the quality of wine, and the higher the amount of alcohol in the red wine, higher the quality of the red wine. So now we need to do some pre-processing. So if we are going to give like if we have um, to take like as 2 to 6.5 numbers of quality, 2 to 2 which is not here, so 3 to 6.5 number of quality, then it is going to show us a bad quality of wine. And after 6.5 to 7 6.5 to 8, it will be going to show us like a good quality wine. So for that we need to actually make bins, and for that bins is equal to I'm going to like increase from 2.5 to 6.5, and like 6.5 to 8, it is actually our bins. Now we need to like make a uh, group underscore names, like we are going to show bad if we are in if the quality of wine is having between 2.5 and 6.5, and it will going to show good if we have 6.5 and between 6.5 and to 8. So um, bad and good. So next line we need to do wine. We are doing it with the with column value quality. So quality, wine quality, and then we need to like use a pd for pandas pd cut. Let me show you some documentation of it. Pd dot cut. Like now you can see like here we have an array of like 175463, and then we have provided it 3. Then it is going to make it as like um, like three. There are going to be like three intervals between them, or I can show you like here. Let me show you. Mm, there are bins is equal to 3. Now you can see like 5, 6, 7. Okay. Like you can see it here, bad, medium, and good. If it is now you can see here, we are having pd.cup and t and p and array. This is our column. Assume this is our column 1756463, and we have bins is 3, and we are going to label it as bad, medium, or good. So 3 means if 1 to 3, 1, 2, and 3, these are all are the bad values. And next, 4 5 is 4 5 6 is going to be our like a good values. Like 4 and 5 will be going to 4 5 is going to be our medium value, and then our 6 after 6 is going to be as a like good value. 6 7 8 is all is going to be a good value. Same thing over here, we have to do like pd dot cut wine of quality. Now we need to specify bins, which is bins, and labels is equal to group underscore names. Now it is going to like cut the uh, cut into the beans. And same thing we can do if the columns is in the values of age. We can give it as age. As you can see in pandas library, they are use cut when you need to segment and sort data values into beans, when you have to sort and convert the sort the data values in the beans. And this function is also useful for going from continuous variable to a category variable. For example, cut could convert ages to group of ages. Like if we have the ages between like 0 to 100 between in a column, then we can group it like that, like 0 to 10 in one group and 10 to 20 in another, like that. We just have to we will be having just 10 type of 10 type of groups over there. So now if I can show you like wine quality, it's like showing us bad 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 because it's all like ranging between 2.5 and 6.5. Let me show you. Like yes, you can see in our header part, there are like 5 5 5 6 5. These are the values which are we have put it into the bad things, bad quality type. Now we need to do it in we need to apply a label encoder over here, because encoder will going to help us in like giving these values as a 0 or 1, because our machine does not understand the values of bad. Like machine only understands zeros and 1. So we are going to change it into 0 and 1, like 0 for bad and 1 for good. So for that we need to do some like label encoder, and for that we have to import sklearn from sklearn preprocessing. Processing, preprocessing, import label encoder, shift and tab. Now we just need to do some label encoding, like of quality of wine. We need to do this label encoding on the features of quality of wine. Let me show you guys. Label underscore quality is going to be as label encoder. We are importing the function of label encoder. Now it's time to do label encoding of wine quality. It's actually if you have heard of get dummies values in my in my previous video of projects, we have done the same thing by get dummies, and but this is a new method to, and it is a really easy method to do label encoding. So we are using it this now. Now we just need to use label quality dot fit underscore trans. We just need to fit our data over here with wine quality. Let me check it if it is right. Right, it is right, and we just need to press shift and enter. Now I can show you guys what label encoder does. Like now you can see all the bad values have got changed into zeros, and all the good values between them got changed into 1. So now I can show you how many good quality of how many good quality of wines over there and how many of bads. So for that we have to just do wine dot quality dot value underscore counts is this a function to count the values of 0 and 1. So there are 1382 zeros and 217 ones, means 1382 are the bad qualities of wine and 217 are the good qualities of wine. So next step we are going to we can also do this on a we can also so represent this on a graph like SNS dot count plot with wine quality. Now you can see it's basically around 1382, and this is actually around 217. So let's move forward. Now we are actually now I want to show you the head of data frame again. Now we have fixed quality, same thing, but we have quality is in our zeros and 1 rather than 5 6 7 8. So now we just need to differentiate the data between x and y for our training and test splitting. Now I am going to put all of the other features, these features, into variable x is equal to wine dot drop quality, and we are going to perform it into columns. So x is 1 is equal to means x is equal to 1 means we are choosing columns, and x is equal to 0 it means we are it means you are using rows. So we need to use columns over here, so we are providing x is equal to 1, and on the other hand y will be y, and this will be only going to be quality. So now you can see capital X is over all of the other columns rather than quality, and Y is over like the quality only. So I think now it's time to do a train and test split. For that we need to um, import another library, not library, another function. Like we need to import sklearn. We need to import sklearn from sklearn dot model selection. Import. Now I need to import train test split. Actually, I've imported this library, which will be going to help me in splitting the data between train and test split. Now, just we need to do extend. These are the some basic steps we have to cover this in every machine learning model when we are making. Now y underscore train, y underscore test is equal to train. This step is actually uh, a must step for every for every machine learning project. I have provided capital X over here, so it's X capital X Y. Text size, we are going to take it as text size means how much how much data we need in our test data frame, which is over here X test and Y test, and it is actually in zero in float values, like I am going to show you right now. X is equal to 0.2. It means 20% of the data we are taking it as a test size, and in train we are going to have 80% of the total data on the test. And now we need to specify the random state. Random state is basically these are all are the parameters of the test train split. You can see it in here, taking the cursor over here and pressing shift plus tab, and now you can see the parameters, all the parameters which are available in uh, train test split. Let me show you where are the variable, where are the parameters. Okay, yes, these are the parameters. Parameters, array, test size, train size, random state, and now I am going to put random state is, you can put any actually any number in random state, and I am going to put it as 42. Uh, Now I need to import another important pre-processing technique, which is called standard scalar, and I'm going to import over here only because it is it comes in the pre-processing part. So I am importing standard scalar over here. Standard scalar. So now I'm going to apply standard scalar for optimizing the result. So now we need to import C is equal to standard scalar function. And okay, standard scalar is not defined. Actually, I haven't. Now it's called. So now I need to import do that on xtrain and is equal to sc dot fit underscore transform xtrain and y x test is equal to sc dot fit underscore transform x underscore test. Now to press shift and tab. Now our training and testing data is ready. Now to perform machine learning algorithm, we are going to use random forest classifier, which I will be teaching you guys in a separate video what this algorithm does and like in behind. So random forest classifier. For that I need to rfc. For that I need to firstly import the random classifier and let me random forest classifier, and we need to put some estimator values over here because this is a important parameter. We cannot get forward without um, giving this estimators. Estimator is equal to like 200. I am giving it 200 and rfc dot fit and x train comma x underscore test. Sorry, y train, y small, not capital, y train, and I need to predict RFC now. So for predicting RFC, we need to do some RFC dot predict and predict the I need to predict what are the values coming from the in our test data, and our test data is x underscore test. So I just need to now shift and enter. And random forest classifier is not defined, so I think I forget to import random forest classifier. For that I'm inserting another column from Scalar dot ensemble import random forest classifier. Just need to press shift and tab, and now it is running. Now it has run. Now I want to see if what are the predictions we have got. So for that we need to also import classification report, and which I am going to import by writing from scalar dot metrics import. Need to import classification underscore report, and confusion fusion matrix. I'm importing both because I will be needing it in future, so I am importing it right now. So next thing is like print classification underscore report. We are reporting it on doing it this classification report thing on our test values, testing data. So testing data y underscore test predict on y underscore test, and between the predict RFC with this and with this y test predict underscore RFC. Now we will be getting a table of like about how good our algorithm has worked. So it has actually worked with 0.90 precision, and it is actually good accuracy. But we can do this same with some different algorithms as well to get the maximum score, and we can also tune it with hyperparameter tuning. But I need to show you the confusion matrix as well. So for that, print confusion matrix. Confusion matrix is same, like we are going to make confusion matrix of these, and I will be teaching you this confusion matrix later on my data science course. It it is I will be covering all these topics in my data science course, which I have started simultaneously with providing courses. These are the projects which will going to help the people who have already learned about the algorithms and all the other things, all the other libraries like pandas, numpy, and seaborn. And you just don't need to learn these library. They have a uh, proper documentation for the all of those libraries. Like scikit-learn has really powerful and really helpful documentation, and pandas also have the really beautiful documentation. And I think if you want to increase the accuracy of this project, you can also apply some other algorithms on this same project. Like you can use forest random forest we have used. You can use SVC, spot vector cross validation, and you can use also you can also use like some other grids, SVC, grid search CV. You can use these types of algorithm as well. Um, so I think I should. You can also use like stochastic gradient descent classifier, but I think we are getting 90% of accuracy, and around 88% of accuracy, so it is a good score. And I think we should finish this project over here, and I will be going to give the link in the description of red wine quality Kaggle problem. So thank you guys, and We'll see you in the next video. Thank you guys.